I am continuing to work through this exam right here. This is the AP Physics 1. This is the 2017 version of AP Physics 1 algebra-based free response questions. I've been working through this. Each question is a video, and I'm just going to continue. And I will put the link down below for the whole test. You can look at it. And I'm doing this cold, right? I haven't looked at this question yet, so it's going to be the first time I see it. I'll work through it just like you'd be working through it on a test if this was 2017, but it's not. Okay, so let's get started. Let me turn off this little thing right here because no one cares. And move my microphone. Okay, so here we are. I've done these questions, and they were just all okay. I wasn't really too super impressed with them. Okay, here I am. Cold reading. First time seeing it. And I know the color is not perfect because it's kind of small. I'll write it bigger. So let me just read this to you. 7 points. Suggested time, 13 minutes. 2 pulse waves are traveling in opposite directions on a string. I guess that's one, and that's one. The shape of the string at t equals 0 is shown above. T equals 0. Each pulse is moving with the speed of 1 unit per second in the direction indicated. Okay, cool. 1 unit. Okay, unit. That's weird. They have this as centimeters, and this is just a unit. Okay. A. Between time t equals 0 and t equals 5 seconds, the entire left-hand pulse approaches and moves beyond point P on the string. On the coordinate axis below, plot the velocity of the string located at point P as a function of time. Velocity of the string. I guess they mean the vertical velocity. Yeah, it had to be, because as this pulse comes by, this point's going to move up, and then it's going to move back down. Okay, so, and if this is moving at 1 unit per second, it's going to take 1, 2, 3 seconds for the pulse to pass. So let's start right here. Let's see, so on the coordinate axis, plot the piece of string located as a function of time between. Okay, so 0 seconds, it's going to be right there. And we're plotting the velocity, so it's stationary. At after the next second, it's still, the pulse is now right here, right? Wait, it's right here, like that. So it still hasn't moved up. And then in between the next 2 seconds, the pulse goes from 0 to 2 centimeters in 2 seconds. So if it's going from 0 to 2 centimeters, so let's say Vy is delta y over delta t. And so delta y is going to be 2 centimeters, and delta t is going to be 2 seconds. So delta Vy is going to be 1 centimeter per second. So that would be right. And that's for 2 seconds, right? Because it's, yeah. This is a weird question. Okay, so that's that. So it goes like this, and then like that. Now it's going to come back down. It's going to go from Vy is going to be delta y over delta t, and that's going to be equal to negative 2 centimeters over 1 second. So that would be a velocity of negative 2. So down here for 1 second. There you go. That's kind of weird. I don't know. It's kind of a weird question. And then it'll be stationary again. I don't know. Not too excited about that. Okay, let's go to part B. At t equals 5 seconds, the pulses completely overlap. On the grid below, provide a sketch. Sketch the shape of the entire string at t equals 5. Okay, let's just say at t equals 5, this first point is going to be 1, 2, 3, 4, 5. It's going to be right there. So it's going to be, let's do this in red. And I know that it's not zoomed in the best, but so it's going to go like this. That's that pulse. The other pulse in t equals 5 is going to be going 1, 2, 3, 4, 5. So it's going to go from here, and it goes down 1, 2, 3, 4 over 2. So 1, 2, 3, 4. It's going to go down here, and then it's going to go back up. So at every point, the graph down here is just going to be a sum of these points. So let's just add these up. So right there it's 0. So right there it's, oh, that's point P. So that's 0 right there. Everything else is just, there's nothing. So I can go like this. And this is going to be 1, 2, you can't see that. 1, 2, 3, 1, 2, 3. So after that it's flat. Okay. Now from here, let's just think about this. Right here, you can't see. Right here, this has a value of 2. This has a value of -2. So these two are going to completely cancel in between those two cases right there, from there to there, right? The slopes are the same and everything. It goes from 0 to 2, 0 to -2. So these two add up to 0. So that's going to be, during that first segment right here, it'll still be 0. Now, right, let's say right here to here. So they add up to 0. But right here, this one is at 1, and this one's at -4. So in the next segment over, it's going to be 1 plus -4 is going to be -3. So down here, I'm going to go 1, 2, 3. It's right there. And I think it would just draw a straight line to that. Let's do that. I'm not positive about that one, to tell you the truth. And then from here to there, they don't cancel, but they end up back at 0. So I think I'm going to go with that. Do any Scratch practice work on the grids on the following page. You'll be only graded for that. Okay. Okay, I finished the test. I might have gotten this one wrong. Okay, and you know, I could do this in Python real quick. That'd be kind of fun, wouldn't it? Let's see. Could I graph this in Python? No, I think I'll pass. I think that answer's okay. I don't want to spend too much time on that. This would be fun to plot and animate in Python, but it might take a little bit longer than what I want to spend on it. So that's it. That's it for the 2017 AP Physics 1 Algebra-Based Free Response. Someone told me to do the Physics C. I'm going to look at some other tests. If you guys like these, I will do some more. It was okay. I mean, I wasn't too impressed with the test. I think some of the questions were kind of weird to interpret, and I don't know. I would have written some other questions, but okay, there we go. I finished the test.